The process of fossilization. Remains from extinct animals are usually either bones or fossils. These are not the same thing. Bones are, of course, organic matter, but fossils are made of stone, not bone. Since a bone is organic, meaning it was once living, it is based on the element carbon. Carbon is denoted by C on the periodic table. All living things are based on carbon. Such organic material will decay over time. This process is called decomposition. When an animal dies, the body starts to break down immediately, and we say it decomposes. First the flesh goes, and then eventually the bones. Stones, however, are inorganic, and they do not really decompose. Stones endure. Mick Jagger is still singing, after all, and he's really old. This is a bad joke, by the way, so you shouldn't laugh, even if you got it. Your teacher probably got it, but didn't laugh. Getting back to real stones, suffice it to say that some stones are billions of years old, with a B. In the bottom of the Grand Canyon, for example, you can see stones that are a couple of billion years old. This is from a time long before the dinosaurs. The dinosaurs are millions, not billions of years old. No bones still exist from that far back in time. When you see a fossil bone of a dinosaur, for example, you are really looking at the stone castings of the bones that disappeared long ago. The stone casting of a bone is the result of a natural process called fossilization. What happens is this: the dinosaur dies and its body is buried in the mud. Then the mud hardens after the flesh has decomposed, but before the bones have gone. So now we have bones embedded in the hardening mud. As more time passes, the bones, being organic matter, eventually dissolve and disappear, leaving empty spaces or cavities in the hardened mud in the shapes of those bones. As more time passes, those empty cavities begin to gradually fill with minerals that are dissolved in the water that passes through the empty cavities. Over much time, the minerals accumulate and fill the cavities and harden into stone. In other words, the bone is replaced with stone. Bear in mind that this process of fossilization requires a very long time, often millions of years. So all fossils have to be at least tens of thousands of years old. The hardening of mud into stone forms sedimentary rocks, which are the only kind of rock that contain fossils. Sometimes bones from even more recent extinct animals are found that did not have enough time to become fossils. Conditions have to be just right to preserve these bones for thousands of years. Ice Age animals are often found in the form of preserved bones, but incorrectly called fossils. So remember, true fossils are made of stone and may be very old. Preserved bones, on the other hand, may be very recent or may go back to the Ice Age, but not older than that. Dinosaurs lived millions of years ago, so their bones have long since been replaced with minerals and exist today as castings composed of stone that we correctly call fossils. How do we know how old something is? There are many methods, but probably the most accurate are different kinds of radiometric dating. Radiometric dating is analyzing the isotopes of certain elements and calculating the proportion of that element that has decayed according to a predictable rate. For bones, we use radiocarbon dating because bones are organic and thus based on the element carbon. Fossils, on the other hand, are too old for radiocarbon dating. They are made of stones, not organic matter. For this reason, we can use potassium-argon dating, which is the other type of radiometric dating, and that can date material from millions, even billions of years.